Webster, switch off the microphone. Webster Daka, switch off your microphone. Webster Daka.
Hello. Hi, everybody. Just checking if you can hear me.
We can hear you, sir, loud and clear.
Okay, so what I'm going to do is, again, I'm going to have to ask if you can confirm, because what I've had to do is I've had to just switch to my phone's audio and speaker, I guess, because for some weird reason this this device is acting up here. Can you still hear me? Okay, thanks.
Yes, sir, loud and clear.
All right, thanks a lot. I don't know what's happening here, and we've lost a bit of time. A reminder that we I think we have a missing class here, right? So I'm going to suggest that we have our epilogue, I guess, if we can call it that, tomorrow, right, at 18 hours, hopefully. And then if there's any spillover or something, we can probably finalize our discussion on Sunday. But I'm planning for us to wrap up this discussion tomorrow, right? So we have class tomorrow at 18, as always. So what I'm going to do is going to attempt to download this thing here, and then we can probably start. As I'm doing this, right? Again, I just wanted to reiterate. I think there were some people that were in the MATLAB and also in 2C that were unable to, or that probably don't know what happened in the main venue. So one of you, and I guess most of the individuals that were in the Michael K lecture theater know the person I'm talking about. This individual was cheating. So this individual was using ChatGPT, right? And they foolishly activated, I guess, audio on the device or something like that, right? And so it was right there out in the open. So it was checked out. And I mentioned, and I'm very serious about this. I mentioned that I'm taking this as far as it goes. Of course, because of procedure, I'm going to start with the department. We'll probably go to the school. I don't know if it's going to go to quality assurance at some point, probably, and then ultimately it will probably find itself with the vice chancellor, right? This is how serious this is. And I don't know what could possibly possess you to do this. And, you know, I see most of you doing all sorts of funny things here, like looking over your shoulder. Even yesterday, right? There were individuals looking over your shoulder, right, to try and see what your colleague has written or something. No normal human being is supposed to do that. And yes, you guessed it right? I am putting it out there that you're not normal if you're doing that, right? There's something seriously wrong with you when you're cheating like that. But yeah, it's quite sad, really. That's water under the bridge. This individual will sort it out himself, or they'll sort it out themselves. I think my job probably will stop with probably the department or the school or something like that. Something else that I would like to do is make an announcement, very simple announcement here. Of course, you're stuck with me until the exam here, but on Tuesday at 8. Now, I'd said that I would prepare a schedule. I'm still preparing this schedule, but at Tuesday at 8, we start with the final presentations. The venue is going to be the computer science conference room. It will be one group at a time, so 5 people at a time, no audience. It will just be me, the tutor, and a few other invited individuals. So we'll quiz you, we'll give you an opportunity to present what you would have done, and then we'll ask you questions. So you will have 10 minutes to do your presentations. Afterwards, we will spend the next 5 minutes or so, not more than 5 minutes, asking you questions about what it is you did. The questions will be tied to the CRISP DM approach or methodology. So we'll ask you questions as they relate to all of those CRISP DM phases, in essence. Okay. With that being said, I also made mention of the fact that because I don't know, Mr. Paul, if you can maybe just mute your microphone, please. I also made mention of the fact that all other deliverables, so the couple of deliverables that are pending, there's a final report, you know, there are screencasts associated with the presentation. They're supposed to be submitted by Monday. So the deadline is 23:59 Monday. So all models must be implemented by then. The reports must be completed by then as well, in preparation for the presentations on Tuesday. Okay, so hopefully this makes sense. I don't know if there's any questions here. I'll pause here just in case people have any specific questions. We do have a class tomorrow, so whatever is going to be left over today, we'll finish off tomorrow. Any questions about the upcoming activities, especially? Wonderful. I may not have a chance to tell you this, but cheating in the final exam should be the last thing on your mind. It gets to that stage and it's tricky like that. Anyway, I guess maybe you'd want to take a chance here because the rules have been relaxed. Previously, if you're caught doing something like this, it's 3 years, is it? You only come back to the UNS after 3 years, but apparently the rules have changed. You know, we are watering down everything here. So it's a year later, you can come back and continue as if nothing happened at all, which is fine, I guess. There are people that are paid to make those rules. I certainly am not. Anyway, so we're going to continue our discussion. And, you know, you guys, we had gotten to a stage where I asked you guys to try out some implementations. I don't know if you did try out these implementations, seeing as you are busy with the test yesterday, but we did something interesting here. We came up with an implementation of a model that takes in numeric attributes. A reminder here that whenever we make mention of the fact that there's a model that takes in as input, or we're implementing a model that uses as input features that are numeric, we are referring to the things we are assigning to uppercase X, right? This 2D structure, right? So if you remember model 1, we said model 1 was going to be created in such a way that we are creating a data frame in such a way that it only has one attribute, is it? So you'd have something like this. You'd have something like this. You have your var, student database, which is our usual data here. If you remember, the structure is the same. I've modified it slightly, but ideally the original data structure is supposed to have 69 columns or attributes. So what we're saying is when we are creating input features to be used to implement the model, right? What we do is we identify the input attributes, right? Input variable, input features in this particular case. And for our very first model, our input was, you guessed it right, our input was the course workload. So what we did was we got this variable here, course workload. In other words, what we did was we got these values here. Now, if you look at these values, right, we can actually check, because we have a restricted set of workloads here. We can check by casting this to a set. We can kind of check the workload, and we see that it says 2 values, is it? There are students whose workload is 4. Some of them have a workload of 5 or something like that. So in other words, we are building this model, which will be looking at the value associated with workload and matching it with what is in this column here called final examination, right? This stuff here. Instead of doing a set here, final examination is supposed to be like this. So in other words, what we were doing is we were saying var uppercase X, uppercase X, and then we were specifying the model here towards the end here is just there to help us understand that we're creating a series of models. So we started off with model number 1, which uses this attribute, right, course workload, as X's. So what we do is we're saying the input has got to be a 2D object, meaning that we use double square brackets here to create this. And in truth to that, actually, if you look at the type of the model var uppercase X, it's supposed to be model F here, it's a data frame, right? And then we do the same thing we do something similar for, by the way, this was supposed to be model, not modef, but model, like this. We do the same thing for var lowercase y model 1, right? We're creating, in essence, a series in this particular case, which ideally is supposed to get this final examination. Right? We want to create a variable that's going to hold the 1D structure. Now, for us to get a 1D structure from the data frame using a particular column or attribute, we just extract the series, is it? Single square brackets here. Now you do the usual, because this has got to be, we are predicting a class. What we said we do is we've got to preprocess first, and then we obviously would, after we preprocess, we obviously would have to transform, is it? So in this particular case, we preprocess by just saying everything that has NA here, we're just going to assume is a 0, and then in place is equal to true. This is just my decision here. And then because this has got to be a categorical attribute, what we do is we can use a dictionary, we can use a replace function to convert these values 54, 66, 38.5, 9.0 into either a pass or a fail. So what I did was I said, I'm just going to check here if something is greater or equal to 45. If this value is greater or equal to 45, tell me the value. So it's telling me that 54 is greater or equal to 45, 66 is greater or equal to 45, 0 is not greater or equal to 45, so it's false. Now, using this information, all I'm doing is I'm saying I'm going to just do a dot as type int or something like that, right? So that I'm converting this true or false into a numeric value, an integer. It's a binary value, 1 or 0, something like that, indicating the status. Is it 1 is pass, 0 is fail, or 1 is pass, 0 is not pass, right? Either one of the two. So we did this, right, which is pretty straightforward, really. And what you notice is that we are following through with those 5 steps. We are saying for us to learn a model, when you are implementing a machine learning problem, we start off with the data, we split the data, we learn the model, we train the model, we evaluate the model, and then we deploy. This is all we are doing. And what I told you was that you should also attempt to do the same thing with these other numeric attributes, right? Like for instance, Moodle hits. Now what you notice with Moodle hits is that it's going to be exactly, not almost actually, well, almost exactly the same. Because what we are doing with Moodle hits is we are again going to the data set, and then we are saying we want to use as features, input features, we are interested in using this here, Moodle hits. So I'm going to copy this, render it. I see that some entries have no corresponding Moodle hits. Some of them do. If we want, we can probably even again gain a sense of the unique entries here, right? We see that there's a diverse number of Moodle hits. You know, there's some students that are obsessed like that. I remember in first year, constantly logging on to Moodle to check that there are updates or something, checking the gradebook and all those things. So what do we do here? Again, the thing we'd have to do is we pre-process, right? So I'll just say fill NA. Again, this is a decision I'm just making on a whim here. It mustn't be like this. Probably I would have to do this in a different sort of manner, right? Rather than assume that if somebody has no Moodle hits, then it's no hits at all. It doesn't make any sense. But for simplicity's sake, I do this. And what I'm going to do is, I would say, to create an input feature, this is model number 2. I'll call this var uppercase X underbar model underbar 2, right? Because this is using Moodle hits. I'll then say this is going to be equal to var student database 2D structure, right? And then I'm going to get Moodle hits like this. It turns out that the var underbar y underbar model 2 is going to be exactly the same as model 1, right? But for consistency's sake, in terms of naming conventions, I'll just say I'm just going to equate this model 1. I'm just going to equate var y model y equal to this student database, and I'm just going to say again, I don't know why I'm doing this, but let's do greater or equal to 45, and then I'm going to say this is going to be equal to this. Is it dot as type int, right? So that just try and check what I have here for var. Sorry about that. This was supposed to be like this, final examination, right? So that if I check the structure of this, right, 1D array, if I check the structure of uppercase X, is this. Again, if I try to inspect var uppercase X model 2, right, if I do a head, it gives me an idea of what sort of values I'm working with. It's Moodle hits. Again, if I do a head, if I check the values for this thing here, it will show me the some sample attributes. 2D array versus 1D array, and then the rest is the same, right? It's like you're doing the same thing. So using these as input, we then again, I'm going to draw attention to I hate it when I'm using a completely new machine and I have to redo things here. Rewire my brain on what needs to be done here. Everything was perfectly configured in on my other computer here, but again, what we are doing is this. I'm explaining this thing here. I don't know where the interface. There we go. Here, right? We are going through these steps. We start with step 1. Step 1, where we start with the data, and then step 2, we split the data. Step 3, we learn the model, we train the model. Step 4, we evaluate the model. Step 5, we deploy. Now this has been tagged as future step here because deployment is actually a lot more involving. It involves a few additional moving parts than we've laid it to kind of seem here. But anyways, so we are going through these steps, right? When we come, what we're saying is that for the model that takes in as input, Moodle hits. The next step is we must course workload. The next step is we must learn the model. So we're doing the same things as here. So we must split the data. We're doing the same thing. Splitting involves us using, in this particular case, we're choosing to use the holdout method. So we use train test split, and then we are feeding it. The only difference here is we're going to be feeding train test split var x model 2 and var y model 2. These other parameters you can alter if you want to. Test size can be 0.3, 0.2, or 0.1, right? Where you're using 30%, 20%, or 10% respectively for the test data set. Now we mentioned that the random state here ensures it guarantees that the results you're going to be getting are the same. Okay? So once we do that, again, we learn the model. Now, what we are doing here is because for model number 2, we are again using numeric attribute. There's no need for us to use a different sort of estimator. We can actually use decision tree classifier as well. So what I'm saying is once we split the data associated with our new data set, which comprises of this, and this, because we figured out that decision trees are okay when we're dealing with numeric input features, we can still use the decision tree classifier in this particular case. Okay, so it's still the same. And what you begin to notice here is that when you're dealing with numeric attributes, for the most part, you find yourself performing fewer number of steps than you would if you are using categorical attributes, for instance. Right? In this particular case, we have an example of campus accommodation. And campus accommodation, a reminder, has 2 values, is it? Yes or no. So we are checking if a student is accommodated or not. Right? So we're going to get this this attribute here, copy paste it like this, and then we're checking for all values. Tell us whether a student is accommodated or not. Again, as part of preprocessing, what you can do is you can get unique values and just check if maybe there are now entries, because this information is coming from an authentic, I want to say it's an authentic course here, which is SIS. You notice here, there are no now entries. I don't know if you figured this out. For Moodle hits, right? This is interesting. For Moodle hits, there are gaps. Why are there gaps? Well, the lecturer was extracting information from Moodle. In some instances, there were instances where Moodle crashed and the logs were missing, and so you don't have hits like that. But information that goes into SIS is really cleaned up. By the time it goes into SIS, for most important attributes here, like exam scores, for instance, they would have already been cleaned up like that. This explains why, for all our students, you will actually have an indication of whether that student is accommodated or not. Now, whether the status here is correct or not is not really a focus of attention at this point, right? You'd assume that the data you have access to has undergone the necessary quality checks as part of data understanding, for instance, or data preparation, if you remember those stages we looked at. Anyways, so we get this. And what we are doing still is we have got to create a 2D array. We're creating model number 3 here. So we've got to create a 2D array, is it? var underbar uppercase X underbar model underbar 3. is equal to, this has got to be a 2D array. How do we get a 2D array? Double square brackets, like this. However, our var underbar lowercase m underbar model underbar 3 is going to be the same as our var underbar y model 2. It's just the same thing. Our labels for the exam score are going to be the same for all the models for supervised learning, because our interest is to determine whether a student is going to pass or fail. The input features are different, but the y's are going to be the same. So in other words, var y model 3 is still going to have 10 10 10 10. However, var underbar uppercase x underbar model 3 is going to have yes, no, yes, no, yes, no. Now here's the thing. There's additional steps that we have got to perform, right? Because we are using a categorical attribute, we cannot use we cannot feed the estimator with yes, no, yes, no, yes, no. What we have got to do is we've got to obviously perform an additional step. So we prepare the data, we've prepared it, x, y, x underbar uppercase y, sorry, var underbar uppercase y, var underbar lowercase y. What we do then is we have got to then split, is it, the data, right? So we prepare the data and then we split it. We are splitting it using the holdout method. Again, because it's the same data set, 273 observations, we're still going to go ahead with using a proportion of 30% for the test data set. Once we split the data, the next step we need to do, and this is crucial here, because we're using categorical attribute. These are not numbers. Moodle hits, if you notice, var x model 1 had numbers, course load, numbers 4, 5, or 0, 4, not a number. Model 2 had numbers, Moodle hits, 42, 0, 0, 0, 44, 39, 58, 23 hits or visits. However, model 3 doesn't have numbers, right? These are categorical attributes. These are dichotomous attributes. So what do we have to do? We have got to transform this data, which is why, as an additional step, after you split it into a training and test data set, what you do is before you learn the model, you have got to one hot encode. Right now, in this particular case, I'm one hot encoding using using the one hot encoder. But what you could do is you could potentially do this. You'd say, what we are going to do is we're going to get this. This is our input here, but we're going to create a transformed and say this is what we are going to feed to the model here. Right? We're going to feed PD. I'm going to use a simpler one. PD dot get dummies. Like this. So in other words, what we are going to do is we are going to create a transformed version of our uppercase X train after we transform the data. Sorry, after we split it up, we use X train. I don't know if I'm making sense here, but just in case this may be confusing, what I'm going to do is I'm going to do this. I'm going to do this, right? For model 3, training, test, input features. Model 3, so training, test, labels or targets. These are going to be equal to train, test, split, like so. Oops, sorry about that. This is going to be this. In fact, what I need to do is, I know I haven't imported these things first. What I'm going to do is I'm going to import these things, all of them, even if I don't need them, actually. I know pandas has been imported, but the others haven't been imported. So we have this this is going to be equal to train test split, but train test split here is equal to var uppercase X model 3, right? And then var lowercase y model 3. At the bare minimum, what else do we want to do? We want to say the test size is equal to 0.3, right? We can even add the random state, but this is fine. So that now what we have is our var X train, the thing that we want to transform, one hot encode, has still yes, no, yes, no. But the yes, no has only 191 observations, 70% of the data. Whereas var test 3 has 82, right? 30% of the data. So from here, now we can one hot encode. So what I was saying is we need to one hot encode pd.getDummies. And then we're going to get var underbar uppercase X train, is it? So we want to get the dummy versions of this. Okay. And then when we do this, we can then say this is going to be assigned to var underbar X. I want to call this train 3 transformed, like this is equal to this. In fact, it gets even more interesting here because I'm not using the one hot encoder, these have got to be classic numerics. And I haven't tried really to see if you can feed the models false and true, and they'll know that false is going to be equal to 1 or something. But to be on the safe side, what you want to do is you'd want to convert this in numeric attributes. So what you can do here is you can say, I'm going to get, and this is an extra step which you could have easily done before, but you say, I'm going to get this, and then I'm going to say dot as type int, is it? And then I'm going to call this again and tell this thing here that the train 3 transformed for this value here, must be equal to this. I'm just overwriting these things. And then for the yes, I guess, I don't know, but for the yes, we're going to do this as well. Right, so that our var X train transformed now has numerics, right? 0, 1, 0, 1, 1, 0 something. Yeah, we know that this combination tells us that the model will know when it's learning. So this time around, even though we are getting an X which has 1 feature, but you see when we one hot encode this, it's almost like we're feeding it 2 features, right? This. You understand this? So you one hot encode, which is here, and then what you are feeding, what you are feeding to decision tree classifier is actually this input here. If you notice, we're feeding it transform. So in other words, what we are saying is that what we would have to do in this particular case is create maybe to showcase this. I'm just going to start from here, create a decision tree classifier like this. And then we're going to fit it like so. Is it? Like so. I think I have, it's 3 transformed here. It's underbar 3. It's the thing about naming conventions. Transformed, right? Like so. Right? So we've learned the model, and this is it, right? Training the model is just running the fit function. Done. After we've fit it, you can then do a prediction, is it? So again, you're going to run the predict function on the test data set. So you come here and say, I want to run a prediction on, and again, we would have to, this is where it becomes a bit tricky here. Whatever we did here, when we're doing get dummies here, we must do the same thing with the test data set. right? So we come here. We would have to do this. Is it? Whatever you do it twice here. So you're saying you're gonna get dummies for the test like this. We're supposed to got the wrong thing here. We want to copy this and paste it like it is here, just in case people can't see here. What we are saying is that we are transforming, right, the test data set as well. It's got, in essence, the format for the test has got to be the same as the training. So again, test will be like this, transformed, like so. So again, we have to convert these into 1010, right? So what we're going to do is we're going to do what we did here, like so. We're just changing where there's train, you change to test. Where there's train, you change to test. Done. We go back here, we get here again, copy this. Again, where there's train, you change to test. Where there's train, you change to test. Now here's the thing. This is a part where you begin to realize, well, I'm better off using the one-hot encoder, because the one-hot encoder will not require you to go through all of these different steps, right? So our input is going to be this, test transformed. So what we are going to do in essence is run inference on using the model that we've learned. If you notice, we learned the model here when we were fitting, right? var underbar classifier underbar 3.fit. We were learning the model using the train, right? The transformed version of the training dataset. For us to run inference, we have got to do a var underbar classifier 3 dot, not fit, but dot predict, is it? But we're saying that we are predicting what? The same input as before. It's going to be var underbar x underbar test underbar 3 transformed like this. You understand this? And when you run inference, we see that, in fact, these things, if you notice, when we run inference on Moodle, I don't know if it's Moodle, not Moodle hits, but the other one, workload, it gave us all ones, right? It appears like we're getting the same result when we're running inference on a model that is created using what? using accommodation status. So you run inference, and true to that, actually, you can compare again, right? You say var y test 3. If we do a list of this, what happens? It's showing us, right? Oh, if we check our test data set, the first observation is a pass. Okay, it's the same as what our model has predicted. Second one is the same. However, and maybe this may not be very intuitive here, but I don't know if this would be clearer if we do this. Maybe not. Wow. Maybe not, but hopefully this is making sense. It's almost like let me try and see if I can pull LibreOffice Calc or something like that. I don't know if this will be a bit more intuitive for people that might be confused. I'm dumbing it down, sorry, because I got some feedback here. I'll keep using our colleague from yesterday as an example here, right? No, sir, I've tried to study, but I can't understand. Well, see, I don't understand this. Come and see me, right? What is this now? I'm also going to replace this like this, much better. And then I'm going to, I'm trying to make sure that people understand. I have a sneaky suspicion there are a number of people that may not be understanding what this is about here. There's going to be space here. Then I'll change this to regular expression. Right. So the very first, the model, when we run inference on the model, and we do this, this is what we get, right? This is the model. The actual stuff is this, right? Now, for the actual, this is the output we're working with. So I'm going to copy this and then come back here, and then I guess this is fine for the model. It's fine, and then I'll paste it here. And then what I'm going to do is I'm just going to convert this, do a text to column or something, so that it's a lot easier, right? And then I'll do a comma or something like that. So what we are saying is that for I'll call these okay, observation 1, is it observation 1. So this is observation 1, observation 2, observation 3, all the way up to, you guessed it right, because we used the 30-20 split, all the way up to observation 82. These are in our test data set. And what we're seeing here is, we can check here. Say if this is equal to this, then I'll say correct. Otherwise, not correct. So that it's a lot easier for you guys to see, right? To say, once we run inference on this, for each of the observations in the test data set, we are checking, is what the model has predicted the same as what is the ground truth? The ground truth is the labeled data, right? And we see here that, there we go, we see here that this is what we have. If this is making sense, this is what we have, right? Correct, not correct, not correct, correct, not correct, not correct. So in fact, what we can actually do here is we can even do a count here, is it? Count if this, oops, count if this is equal to not, no, count if this is equal to correct. So we see that out of the 82, you see this? Out of our 82 observations in the test data set, the things we're using to test, only 46, yeah, have been correctly identified. So it's like, oh, what is the accuracy, right? Out of 82. Well, the accuracy is 56%. This is how this is computed. Anyways, actually neither here nor there. Hopefully this is making sense here. Yep. Yeah, so you predict, and then I just have something I'm calling deployment, which is really not deployment, but I'm just showcasing how a completely new observation will be tested. Now imagine this, right? You built an application like this, and new students come next year. What I'll do as a course instructor, if I'm using this application, is I'll just ask the students, or go in SIS and check which students are accommodated and which ones are not accommodated. Or I'll ask them, tell me if you're accommodated or not. And then I'll run, using this very primitive model, right? I'll run inference on those new things that the model knows nothing about. They're not even in the labeled data set, to try and generate something new, right? So I'll just tell the model to say, I have this new student, right? Ebenezer, and she's accommodated. Tell me, is she likely to pass or fail? Now you begin to notice that building a model like that is a bit primitive, right? It's too crude, right? It turns out that most effective models will use more sophisticated features, not individual features. So in fact, you would combine the features, right? But anyways, so what I was asking you to do is, in addition to this accommodation, campus accommodation, what you do is you do the same for minor classification, I say. And then more importantly, because all of us are working with text data, it's like, how then do we work with textual content? Well, if you've been following through, you'll notice that the idea is the same. as when we're dealing with categorical attributes. We have got to transform, and this is the reason why we spent a bit of time learning how to transform the data. All the steps are the same. Observe. Here, we start with our data, our labeled data set. We split the labeled data set into a training and test data set, right? Maybe we've been using 70-30 split. And then before we learn the model, right? And this is a part that I did not include here. I'm going to convert this as separate here. Where applicable, you transform the data. Now, transforming the data is dependent on what type of data attribute you're dealing with. If it's categorical data attribute, one hot in code, right? If it's textual content, you guessed it, we can use one of those count vectors we discussed. Is it TF-IDF or count vectorizer? So in this particular case, what we are saying is that we are reminding ourselves that using our map, before we start everything, using our map, we realize that our scikit-learn map, we realize that when we are working with text data, remember this? When we are working with text data, where is that? Here, right? Naive Bayes is appropriate, for instance. You understand? So we would probably want to use an estimator that implements the Naive Bayes algorithm or something, which is why in here we are saying we're starting off at the very beginning to say for us to implement a model that takes in as input the comments from the students. It's interesting and maybe funny at the same time. What we are saying is for this model that we're about to start looking at, we are saying that we suspect that the motivation, the stated motivation of students, the things that the students are telling us are the motivations for why they're doing this course, will influence their outcome, right? And the thinking here would be, well, maybe somebody who was forced to do a course by their mother or their father is unlikely to pass this course. But somebody who truly is genuinely interested about learning or finding out how computers work has a higher chance, right, of succeeding in the course. You know, so we are. It's like the factor we're looking at here is how motivated are you to do the course, and we are using your subjective comments, right? That we asked when we distributed this survey. So we're using this as input, right? And because we're using this as input, this is text. So we use multinomial naive Bayes, multinomial NB, right? Now in here, I'm just specifying that some of the key parameters for multinomial NB will be the alpha value, right? It's a smoothing parameter really. But the default value is 1, right? And you can get away with a default value of 1. You don't really have to obsess about this. And then what we're doing here is we want to implement 2 additional models. So in actual fact, even though we are implementing model number 5, in actual sense, we are going to implement model 5A and model 5B. Model 5A uses TF-IDF. Model 5B uses count vectorizer. This is what we are doing. Or, instead of being specific here, this uses a bag of words. And then this uses TF-IDF. And the reason we're doing this is simple, right? We want to go for a model that is more effective, one that has a higher accuracy. You know, if that will make it a lot easier for you to understand. So in terms of the things we're importing, pretty straightforward. We import the trend test split function because we want to be able to split the data, right? And then for us to make use of naive Bayes implementation, we're using multinomial NB. And what we do for us to use multinomial NB is we're saying we're going to import from sklearn.naive Bayes, naive _ Bayes, we import multinomial NB. Notice the only difference here is the way the scikit-learn library is organized is you import these things in a certain type of way. For decision trees, because there are different types of decision trees. Observe. we are doing this. I'll just say import sklen like this. And then we're saying that for decision trees, we import them from sklen.tree, right? This is where we get them from. The different types of implementations, right? For naive-based implementation, we import from sklen.naivebase. In this particular case, I'm going to use multinomial NB. Okay. So we import that, and then we need to also, because this implementation, this model is going to use TF-IDF, we have got to import TF-IDF vectorizer, is it? We're importing it from feature extraction.txt, right here. We're just, importing matplotlib here and seaborn because we want to graph some of these results as part of the evaluation. Pretty straightforward stuff. And maybe in case I need to showcase examples here, I'm just going to, again, just copy these things as they are. Copy this import statements like so. And come here, and because there's a new line here, I'm going to say TF-IDF vectorizer, like that. And then I'm going to import seaborn and matplotlib. Seaborn is just, I think I mentioned this, right? It allows you to easily plot certain things, like confusion matrix is easily rendered using seaborn. That's why I'm importing it in here, right? So I do this, and then what do we do next? Well, we are doing our pre-processing tasks, is it? We read the data, and then we decide to drop any entries that are now or something. In this particular case, I have. I'm just going to go here, and I'm going to. I want to do this. It'll be a lot easier if I do this. Model F is going to be var student database like this. Final examination, is it? Right? So I'm getting this, and then I want to drop. What I'm doing here, by the way, is I'm saying I want to, because I don't want to include observations that have now entries. I'll just exclude them like this, so that my model here, my resulting model, this will only have, instead of 273 observations, it will only have entries for observations that have text for both the exam and the text. Because we are collecting this data, if you remember, I explained that this data has been collected using a self-administered survey, and it's optional. You tell the students it's optional, right? For ethical reasons, you don't want to force them to respond. And so for this to make sense, we do this, all right? And then we do the usual. In this particular case, I will not assign. I'm not going to assign. I'm not going to assign. I'm not going to assign var model df4 to df3, right? Because there'll be a mismatch, is it? df model 3. I don't know if I had model. Is it model? No, var model. Model 3, if you remember, model 3 doesn't have the same size, right, as what we've created here, because we did not drop NAs by looking at what is missing from motivation and exam, right? So what I would have to do is I would have to do this. Create a completely different structure, and I'm just using a different sort of syntax here to say, can you create an additional field, right, to this model here, underbar, this model df4 underbar at the end. Create an additional field here so that towards the end here you have a new column that tells you whether 54 is a pass or fail, 22 is a pass or fail, 43 is a pass or fail, right? and the rest is the same here. What's important though is after we split, right? Again here, we're gonna split up our data set into a training and test data set. But we're before we split it, we have got to create uppercase X and lowercase y, is it, for model 4? Yeah, model 4 like this, and this is going to be equal to, you guessed it right, here we're just getting motivation, so we're going to say model df underbar thing, create this as a 2D structure. Very important, right? 2D, create this lowercase y, right, as a 1D structure, but this 1D structure is going to use as input status binary, like so. So that var lowercase thing model 4 here has this, the text, and var underbar lowercase y model 4 has 101010. The key thing is that the length is the same here, size 111 111 here. And then once we do this, we can then do our train test split, is it? And the train test split works in more or less the same way. All we are doing is we are saying we're going to use the train test split function. We're going to use this, but this time around train test split is going to take in as input what? It's going to take in as input var uppercase X model 4 and var lowercase y model 4. And then we can use the test size is equal to 0.3 so that we are consistent. If we wanted, we could have used the random state 42, and now we are beginning to see why this is important, because for you to truly do a comparison between these different sort of models, you want to make sure that the factor, because the way you are splitting the test and training is a factor, is it? You want to make sure that the same observations that are in your training for all of these different models are the same. Although they may not be the same in this particular case because we have 101 observations, but that's neither here nor there. Anyway, so we come here, and then we now have our var underbar X train 4, like this. Text, 77 of them, and then we have our var underbar test 4, right? These. And then we have our var underbar y model 4, these. Sorry, var underbar y test, like this, and also train, like this. Do you understand this? Anyhow, it's pretty straightforward here. Now herein comes the part we were looking at right before. So we split our data set. Then what we do now is, surprise, surprise, we have got to transform. And how do we transform using TF-IDF? Well, we create an instance of TF-IDF vectorizer. This is as simple as it gets here. You can omit the stop underbar words here, but we want to remove the stop words, right? So we transform, right? We create we create an instance of TF-IDF vectorizer, and then we fit and transform. We must fit and transform, right? Because we want to generate something that is actually going to have those values, the TF-IDF values. You understand? I'm going to go back here so that we copy paste the stuff. Create an instance, TF-IDF vectorize, and again, the naming convention is done in such a way that I know that this is model number 4. And then we have got to transform the training data set. Because guess what? Our X, our X here, this is text. We cannot feed this to multinomial NB. It has got to be converted into numbers. How do we convert this into numbers? We use count vectorizer, is it? We create an instance of count vectorizer, which is this. And then we use this vectorizer we've created to fit, is it? To fit and transform this text here. So that what we have here is what we introduced as, you guessed it right, a sparse matrix. Is it? This. Yeah. Now, the interesting thing is the way this, this, I don't know if you find this interesting. Almost everything is interesting, I guess. The interesting thing about, I don't know why I'm something off. Okay, I have to transform this again because I'll need it as input when I'm testing. So I'm going to do it right away. For the test data set, this is for the train, this is for the test data set. So for the test data set, I have got to do the same thing. Because when I'm running inference, it will expect this thing to be in more or less the same format, right? So I'm creating a sparse matrix for both xtrain, this, right, and xtest, this. I don't know if you guys understand here. And then the interesting thing is when we're learning the model, right? Very simple. Please remember that graph I kept showing you, where data modeling has a much shorter bar plot, right? So we create an instance of multinomial naive Bayes or multinomial NB, boom. And then afterwards, when we're learning a model, we just run the fit function, right? We have got to run fit on, observe, we are running fit on this sparse matrix here. At no point are we saying we're going to convert this into a dense matrix. The only reason we're converting those things into dense matrices is so we could understand the values, because it's difficult for us to see these values, is it? We've got to create a dense matrix, right? We were doing this, if you remember. But we don't have to do this in this particular case, right? Right. So we create an instance of multinomial naive Bayes like this, and then we fit the classifier. We train it. There could be something we have done wrong here. Just try and see. 4. This is 77. How about X? Ooh. X train 4. This is also 77. I don't know why this is. Oh, maybe we may have made a. I think we made a mistake when we were fitting and transforming this stuff here. Here, if you notice, there's a problem. Observe the error we're getting when we try and fit here is it's telling us that the input variables are not consistent. They're different. And true to that, if I do a var uppercase X train 4 transform, or is it transform and then 4? There's something off here. We have a 1-by-1 matrix. It's not supposed to be a 1-by-1 matrix. Let me just start. You see now, this is vectorizer. And then I'm going to transform this into this. And then I'm going to check this train transformed 4. There's something a bit off here. Let me just check. There's something off here, and I'm trying to figure out what could be the reason why we are getting back. We have this as our corpus. And what I'm going to do is I'm going to call this different variable here. I'm going to call this underbar train, right? Check it. and then I'm going to say fit transform. What I want to do is I want to fit and transform var x train for I think I have an idea why this is the case. I do apologize for that. I will have to, I think I have a sneaking suspicion why this is the case. It's the size, is it? Is it the type? This is crazy stuff. It's this. Observe. What I'm going to do here is I'm going to say I'm going to create a train like this, and then I'm going to say vectorizer for train dot fit transform. Is it? If you remember how we were transforming here, the way we transform this is we're going to say var x train for like this, right? This is better if you notice. So the input is the input for the way that the fit and transform works for TF-IDF, right? In fact, these count vectors we're looking at is you need to input it with a series, right? So it's a series like that. So I'm going to come here, and then once I fit it, I can then do the same thing. I'm going to create a different count vectorizer for test. Right, and then for test as well, I'm going to do what I did here. I'm going to fit test. Is it like so? Fit test like so. Right? This is better. And then afterwards, once I do this, I create an instance of multinomial classifier like this. And by the way, one of the reasons why I have got to do this, and I'll have to kind of apologize here, because when we were looking at how to create these things here last time, it turns out that and I know I was supposed to be assigning the variables here. It turns out that what we were doing is we were fitting and transforming, right? I don't know if you remember here. We were fitting and transforming when we were just learning how to do this. But yeah, anyways, so what I'm going to do here is roll back here. Is it here or something? Motivation train. I'm going to go back to test here. Test of train. So this is it. I think it is. Or I'm just going to use the most recent one. Apologies for that. Come here, fit and transform. What I'm doing when I'm fitting and transforming is I'm going to assign this to this. This variable here, I fit and transform so that this structure is going to be consistent, is it? 77,292. And then what I am again going to do is I'm going to do the same thing for testing, right? So I'm just going to change this to test. Test. All right, and then what I can do now is I can learn the model, right? I create an instance of multinomial NB, and then I learn the model, right? The way I'm learning the model is I'm going to feed it. Now this should work because the structure is the same, is it? I hope. I think so. I think the structure is the same. So it's like if you check the shape for VX train transformed like this, right? This is 77 by 292, right? If we check the structure for this 477 as well. So what we're going to do is we're going to say, help us learn this model and fit it, and we've done, right? It's trained. After we train this model, we can then try and predict, is it? Right? So for us to predict, again, we need this. It has got to be in the same format, right? So we run inference, or we run the predict function, and then we feed it. We feed it the transformed test, right? We have got to feed it the transformed test. And this is oh my goodness, this is why the issue is as well. I made a mistake. The model we're supposed to use, right, is supposed to be the same as the training data set. I don't know if this makes sense here. It's almost like when you're using this as this is an overall data set which has 111 observations, right? When we say we are going to get the training data set for 4, this will have 77, but this 77 here will have a completely different vocabulary, right? So in other words, you know what we have got to do for us to create the input we're going to use in here has got to be done in such a way that this uses, where is it? It has got to use the same vectorizer, right? Because that vectorizer is going to have the vocabulary we want. So we're supposed to use train here. Now, because we're using train, we just transform. We don't fit. It's already fit. We just transform. And what we do is we are transforming this by feeding it var x. We're feeding it using var x test 4, like this, I believe. And then now we can run inference like this. Now I don't know why we ended up with one observation here, but I'll have to check. So just take note of the fact that you see, when you split up your data like this into a training data set, this training data set has 77 text, right? 77 of them. This text here, once transformed, we'll have a specific number of words in its vocabulary based on this 77. Now, if you decide to fit and transform a completely different vectorizer, there's going to be a mismatch, right? The vocabulary size for what we've trained is going to be different from the vocabulary size for what we want to test for. So for there to be consistency, what you do is you say, you fit and transform for test data, and then you transform you fit and transform to training data, and then you transform for test data. Otherwise, there will be mismatch. Hope this is making sense here. I'm just curious as to this here. Let me just check here. Maybe a bit tricky thing here we have in our test data set. I don't know why it has 1 there when we're supposed to have a total of 34 items. So I do believe it may have something to do with this, so that when we click on transform, there we go. So I had to stretch it out. Now, so the thing here is that when we test our predictions for what is in the test dataset, the 34, this is what we are having, and we can also compare these with what is in the Y, is it? var Y, and then we have our test. So var Y test 4. So in other words, we have this. These are the predictions for the model, and then we do a list like this. Forget about the NP here, it's NumPy. But you can, what you want to pay particular attention is to the things that are in the parentheses here. So 1 for 1 here, another one, another one, another one, right? So you can clearly see 1, 2, 3, 4, 5 ones followed by 0, 1, 2, 3, 4, 5 followed by. This is pretty decent actually, pretty decent, right? Anyways, hopefully this is making sense here. I figured would go through this before we transition to looking at multi-level classification and then doing a very mild introduction to unsupervised machine learning, which is going to be tomorrow at 18 hours. But here's the thing. What I would want you guys to do is, at your own time, I'm asking you to kindly see if you can do the same thing. However, this time around, what you're doing is, instead of using the TF-IDF count vector, what you're going to use the bag of words model, so count vectorizer. And let's try and see if you can come up with this implementation. Right? Now, the other thing I wanted to highlight here, and maybe I can talk about this later on, is that what I'm from showing you from model number 1, 2, 3, 4, 5 is trying to illustrate to say, when you're doing this in a real world setting, you're going to have to check the important metrics associated with the model. So you say, well, for the model that uses campus accommodation as a feature, what was the accuracy? How about the one that uses workload? What was the accuracy? How about the one that uses Moodle hits? How about the one that uses the motivation from the students? And then what you do ultimately is you choose something that has a higher score for whatever metric you're using. Right? In this particular case, I'm showing the metrics for accuracy, precision, and recall. And if we're just to focus our attention on accuracy, we see that it makes logical sense that so far we would have to choose the 63. Now, what would be interesting is to see the performance for the one that uses the text, is it? All right, that would be nice. I'm going to come here and attempt to build a classification report or something like that. Test and all of those things. Let me just see if I can do this. Print like this. I don't know if I will be able to, because I'm looking for the predictions, which are here. Here, I'm looking for these predictions here. So what I'm going to do is I'm going to say, I'm going to assign this to, I'm going to assign this to var y predict 4, var y predict 4, and then assign this to this. And then I am going to get the test as well. So the var y test. So I'm looking for the var y test 4. I'm looking for these. I'm going to do a comparison. For var y test is there. So what I'm going to do now is I'm going to say this. And then try and see if I can do this. I wanted to generate a classification report, and the reason I wanted to generate a classification report is I was so hoping that the accuracy here would be far better. If you notice, if we just use TF-IDF, we see that the accuracy is 53%. And if we go to here, 53% is comparable to campus accommodation. So our best model so far is the Moodle hits, right, which has 63%. Now, we are not yet done, right? Because typically, you must think here. Now is the part where we double back and remind ourselves that in as much as we have a campus accommodation, Moodle hits. I have no idea what else we have here, but we have workload. Now we have motivation. What we've done is we've just implemented models that take in these single, right, features. And we have corresponding, accuracy scores, precision, and recall and stuff. But the question is, by the way, what if I call this not account, but accommodation? If I call this CA, Moodle hits is going to be called MH. Workload is going to be W. Motivation is going to be M. Now, the question you should be asking yourself is, if you remember our discussion of evaluation, but what if we combine, this is model 1, model 2, model 3, model 4, something. There are other models in between. But what if we combine, we build a model that takes in as input campus accommodation and Moodle hits? How would this fare? And the idea behind this is you would then come here, you'd come here and you say, well, var student database, you want to get var student database, you want to build a model that has this campus accommodation and Moodle hits, like this. So this is going to be your X. Now you're not done yet, right? Because if this is your X, what you'd have to do before you start, after you split and test. So this will be your X. And I'm going to call this, I don't know, I'm running out of model numbers here, but I'm going to call this var model. I don't even know what we were calling these things here, but var X model. I'm going to call a CA plus, this is crazy, CA plus Moodle hits MH is equal to this, right? And then we are going to say var Y Moodle CA plus MH is going to be equal to, var student database, like this. We're going to get final examination, surprise, surprise, greater or equal to 45. And then we're going to call this as type int, yeah? So that var Y model CA plus is going to have 273, just like var X model is going to have 273. And then what we do is we are going to say we train and split, is it? So we do the usual stuff we are doing. It's crazy also. But the usual stuff we are doing where we were saying for the but that's okay also. I don't want to mess up the things we are putting for training and testing. I want them to be of the same number. Okay, var X train. So we're going to come here and say var X train and followed by the model itself. This model is called CA plus MH. CA plus MH, comma, boom, var test CH plus this, comma, boom, var lowercase y train, boom, var lowercase x test like this, lowercase y like this. This is going to be equal to train test split. What are we train test splitting? Var uppercase x model. Come on, model, right? CA plus like this, comma var up lowercase underbar lowercase m model CA plus this, and then test size is going to be equal to 30% like this. So that what we have now, right? Var x train CA plus like this. You have two variables if you notice, right? Now these two variables. The interesting thing about these two variables is that one of them is numeric, one of them is categorical. The idea is the same. What you do is you have got to convert this. You transform this. So you're going to come here, and what I would probably do myself is I would say I'm going to get accommodation like this, campus accommodation like so. This, and then if I want to use get dummies, right? I'll come here and I'll say pd dot get dummies. Come on, really? Get dummies. I'll do this. And when I do this, when I do get dummies, I would have to, and by the way, this is the part where I say, well, but what about prefix or something? Is that prefix? I think there is. Campus accommodation. Right? I'm going to do this, but because I'm doing this, I'm going to say, I'm going to have to convert this somehow into, and at this point really, I can already, I don't know if I can convert this, but maybe not yet here. Okay, that's okay. I'm going to come here and then I'm going to say var here, because the input I'm working with is this. I'm going to copy this, and then I'm going to say pd dot concat. If you remember this is why we're learning these things, right? I'm going to concatenate what I've converted this on axis is equal to 1, so that I, and this, you guessed it right, this is going to be a list like this, I believe. So that I have a resulting, and you know, I should have called this something else here. Observe, I'm just going to say this underbar is going to be equal to this, so that the next time I'm doing this, I'm going to create this new data frame, which is going to be a concatenation of these things. A concatenation of these things here. Concat. Concatenate. I want to do a var. I want to create this to be equal to this here, so that what I have now is this. You see this? This is what I want, is it? And what I'm going to do as part of the processing now is I have got to convert these one hot encoded things the way I was doing them, right? So I'm just going to come here and say, well, please convert this, or convert this into, and you can convert this into in whatever form you want, right? I'm going to convert this. Wow. I want to convert this into var x train CA plus. This is insane. Convert this, and then also convert the yes into 101010, like so. You understand? So that when I have this, it now has, in actual fact, what I'm going to be sending to the model are going to be hits, campus no, campus yes. No need to worry about, oh, but what about the order item? Should campus yes come before campus no? Should campus no and campus yes come before model hits? Nope, doesn't matter. Do you understand here? I know we've been we are looking at quite a number of things here. We're looking at quite a number of things here. So the idea here is that these things that you have here now, because we've split it into a test and training data set, we can now feed it to transform, is it, a 2D structure. So I can and what we're doing here is, because these are there's no text here, right? We can use decision trees. This is fine as well. So we can use our decision tree to fit this, but take care of the fact that what we are sending must exclude this, the campus accommodation, this yes no, because this yes no is represented by campus accommodation no and campus accommodation yes. If you get the drift here. Now, so what you would do here is you'd say var. I'm going to do this again. We're just going to, I want us to be consistent with the naming. So I'm going to come back to where we have a decision tree classifier, so that we are all on the same page. But we need to create a completely different decision tree classifier. So I'm going to name it this, copy. And what I'm going to do is I'm going to call this underbar CA plus Moodle hits, like this. And then I'm going to fit this CA plus Moodle hits dot fit. Now, when I fit this, right, what I have got to do is I'm not feeding it, and herein lies the thing. So 2D structure, quite all right, but we're feeding it, but I cannot feed it this because it has this here. What I'll have to do instead is, you can choose. Some people like dropping, so you drop this column so that you just remain with what you need. But what I like doing myself is, in my code, I'll just say, give me this. Give me this. If you have a lot of columns, maybe you'd say, well, this is too much. But I'll say, give me this and give me this as well. Like so. So this is what I'm going to feed as input. So true to that, I will come here and I will say, get this. And then I'm gonna run this model, right? Instance of decision tree classifier. I'll say dot fit, and then fit what? Fit this. By the way, you know that sometimes if you look at my notebooks, the ones I've used in the past, right? I name these things because my notebook would be cluttered. It would be a very lengthy notebook, right? So what I'll do is I'll name these things in a certain way. If I'm experimenting with different models, decision tree, name, base, and stuff, I'll be putting them in my name here. So it will be called var underbar DT or decision tree underbar classifier with the other factors, so that I remind myself of what is there in the thing. We forgot the Y here. So it will be var underbar Y train CA plus, like this. So we've learned our model. Now, after we've learned our model, right, we've fit it, we've trained it, what we can then do is we can do a prediction. Is it the same thing we were doing? But the prediction in this particular case would have to take into account the fact that this var X test that we are using, var Y, we are using var X test, this is not in a form that we need to use. The format must be the same as var, it must be in the same format as this. This is what, when we're testing them, when we're predicting, we need to convert it into this. So what do we do? Well, we are going to have to, and I'm trying to see if we can, I guess we can use the same approach we used here, and then we'll drop whatever we don't need, is it? We're going to create var test is equal to this underbar mh underbar, sorry, is going to be equal to this. I don't know why I used uppercase M here. It's crazy also, but it's okay. It's supposed to be lowercase m. I don't know what's happening here. So we have this, right? Now, because we have this, we have got to say we want to one hot encode campus accommodation. This campus accommodation. You know, sometimes I don't understand this. I have to copy paste, I guess. Uppercase C, is it? We want one hot encode this. How do we do this? The same thing. Everything is the same in life, ladies and gentlemen. PD dot get dummies. We do this, right? And then we can even add a prefix is equal to campus accommodation, like this, right? Once we do this, what we have got to do is merge this, is it? By running PD dot concat. Yeah, we shall merge. We shall merge with concat. We shall merge with this original. Crap. This was supposed to be this. PD dot get dummies. This comma PD dot get dummies, like so. Like so. Access is equal to 1, like this. This is what we want to do. Now, all we're going to do now is we're going to say var x test CA plus MH is going to be equal to this, so that our uppercase X test has more or less like the same structure as what we had before. The same structure as we had before can be obtained by splicing out what you want. If you want, you can drop. What most people prefer to do is to drop, because you typically be dropping fewer records than you can type here. I prefer to use this myself. I don't like deleting, because there are instances when I have to go back and redo some of these things. So this is going to be our input when we're predicting. Now remember, we created a var classifier CA plus this, right? This decision tree classifier. We can then run inference on this. Predict. What are we predicting? Predict this, sir. Yes, here. You understand? Copy paste. So we predicted. We run inference like this. And if you want, you can do comparisons. But I think what will be interesting here is to say, how does combining Moodle hits and campus accommodation compare with just Moodle hits and with just campus accommodation? This is what we're doing here. So what we do, we run our classification report also. What I'm going to do here is I'm going to assign this to here. This is equal to this. But you know what I'm going to, where the hell is this thing? What I'm going to do is I'm going to come to the beginning. Oh my goodness. And I want to call this var predict something here, like this. This is var predict. This is CA plus MH, like this. So that I have var y, come on, var y predict, like this, CA plus. This is my prediction. What is my test? Var y, ooh, what is this now? Test CA plus. So in other words, what I'm doing is I'm gonna run my classification report to check if what is the result here. These are my predictions, right? That's my inference, and then these are what are labeled. Jesus, these are my predictions. This is what is actually labeled, like this, and then I can run inference. So what I can do then is I can say I'm going to run a classification report. Boom, like this. In the interest of time, I'm copy pasting. I'm copy pasting this so that it's a lot easier here. I'm going to copy this. And then I'm going to have this here so that I have a nicely formatted classification report. Is it? But in here, my var predict is what? This corresponds to this here. I'm going to copy this, paste. And then var test 3 is not var test 3. This must match, right? The size. It's actually this. And if I run this, what it's telling me is there's a little bit of hope here. Accuracy, when we combine, what the hell is it? When we combine campus accommodation and Moodle hits, just pay particular attention to accuracy here, this, 57%, 0.57. Now, remember this. Towards the end, I did you guys a favor and I said, look at this, the comparison is this, yeah? Already, we see that using, and this is weird here. I don't know what we are, but when we get, when we combine campus accommodation and Moodle hits, we get 57. But when we use accommodation alone, 53. When we use Moodle hits alone, 63. I don't know if this may be off. I think I was using Moodle weights here, not hits. There's a field called Moodle weights. But if you've been paying attention, you guys, oh, I don't know what we did here. What I wanted to showcase the result, the classification report here. We've done quite a bit here. I wanted to showcase so that we could see the results. Is it? You guys, are you following through? Remember, accommodation was model number. I don't know if you're even there here, but it was model number test. Was that 4 or 3? What was that? Campus accommodation alone was 3. 4 was, please be, it's garbage. 4 or something else. How about 2? 2 is not even there. 1 we did last time. Okay. I wanted to do a comparison to showcase to you that as you are combining these features, when you are combining these features, when you are combining these features, the accuracy actually improves. And so what you do as a good scientist is what I'm showcasing here. There's going to be a model which combines campus accommodation and Moodle hits. Campus accommodation and workload. Campus accommodation and motivation. There will be a model that uses Moodle hits and workload. Moodle hits and motivation. What else? Workload and motivation. What else? Campus accommodation plus Moodle hits plus workload. Right? What else? There's quite a bit here. And then finally, towards the end, you're going to have something that has all of the attributes: campus accommodation, Moodle hits, workload, and motivation. You know that there's a thing, right? What do they say? What do they say about pairwise comparisons? If you have, okay, these are pairwise. These are not pairwise comparisons. We're looking at combinations of things. Not so combination of things. This is quite complex because we have 1, 2, 3, 4. We have 4 different attributes. So either we can combine them 2 at a time, or 3 at a time, or all 4. And when you're doing this, right, you'll find that some of the combinations are going to be crazy. Campus accommodation, Moodle hits, workload. Campus accommodation, Moodle hits, motivation. Is it? I don't know what else I've left out here. Moodle hits, workload, motivation. Okay? I don't know. Moodle hits, workload, motivation, and so forth and so on. So the idea is you have got to empirically determine here. Now, you see, some people sit there and think, but this is too much work. No, it is not. By the way, this is somewhat implementation / evaluation, right? You are hunting for something that will have a better accuracy. I'm going to pause here and mentioned that tomorrow I'm going to walk you through multi-label classification, but the idea is the same. I'll share this slide so that you can already look up this information, and then we can maybe quickly look at unclassified unclassified or unsupervised rather machine learning, right? I'm going to pause here just in case there are questions, but I needed to talk to you about this so that at your own time, what I would like to ask of you is you guys must build a model that combines all of these fields we're looking at. In an ideal case, ladies and gentlemen, in an ideal case, what you would be doing is you'd be saying, well, I have this. I have this. What columns can I possibly use to do inference? You identify them. Maybe out of the 69, perhaps 20 of them, 20 of them would have to be potential candidates. Well, we didn't discuss some of these things like dimensionality reduction, and also coloration, right? Because sometimes some of these attributes you're seeing will have the same effect on the result. And if they have the same effect, you don't have to implement two models, right? I don't know. For those of you that are still online here, is this making sense? Are there any thoughts or questions? This is 14 hours, I guess. If there are no questions, what? See, what is the format of the report? The format of the report, Mr. Mwenyasha, read the specification, right? SEM formatting. Sorry to interrupt, but software engineering stream of project presentations. Yeah, 14 hours, which is now, okay? So today, at the last day, no, it's not the last day, Moses. We have a makeup class here. No, but I thought you learned a lot before. You know, you guys, presentation. Okay, listen, you guys, I will see you tomorrow, 18 hours. We have an epilogue class, please. Mr. Mwan, I saw your email. Mr. Mwani Mhango. I shall do the needful. Thank you very much. Good luck with your presentations. Please prepare for our presentations. You shall present on Tuesday. I shall be sharing the schedule. Best wishes. Bye for now. Don't know if I was talking to myself. Yeah, I don't know. Joshua has a crying emoji. I don't know what that means here, but it's neither here nor there, I guess. Okay, bye everybody.